So, ayun guys, no? So, let us continue our topic na double integration method by solving this example problem number 1. So, basahin ko muna yung problem guys and then let's solve later on. A simply supported beam, 10 meters long, carries a uniform load of 24 kilonewtons per meter. Using the modulus of elasticity equals to 200 gigapascal and moment of inertia equals to 240 times 10 to the 6th millimeters to the 4th, determine the rotation of the beam at a point 4 meters from the left support in radians and determine the deflection at a point 4 meters from the left support in millimeters. Okay, so bali no, opinion ko lang to guys no. So actually no, ito yung mga pinaka madadaling problems ng double integration method kapag ka isang segment lamang no. Pero actually no kahit kung para kung beginner ka, I think madali lang yung isang segment. Pero kung medyo sanay ka na sa mga pagsosolve using the double integration method, no, kahit gaano pa complicated yung beam, masosolve mo yung problem. Okay? So, ganun guys. So, ang gagawin natin guys muna, no, is para magkaroon tayo ng idea, ay i-drawing muna natin yung elastic curve. And then, titingnan natin sa elastic curve kung ang i-expect ba natin na sign ng rotation at saka ng deflection na tinatanong sa A at saka sa B ay positive or negative. Okay? So, ayun. So, dito tayo sa whiteboard. Ayun. Okay, so dito sa whiteboard guys, ay nag-drawing ako ng elastic curve. So, itong orange na to, ito na mismo yung elastic curve. So, ang hinahanap natin guys dito is yung rotation and deflection at a point 4 meters from the left support. So, ito yung ating left support, dito yung ating left, and dito yung ating right. Okay? So, ibig sabihin guys, no, since symmetrical yung ating beam, then automatically, yung ating lowest point will be at the center. Ito yung ating maximum deflection. Pero hindi ito yung tinatanong. Yung tinatanong is yung slope and deflection at a point 4 meters from the left support. Ito yung ating 4, sabihin natin nandito yung ating 4 meters. So, ang ine-expect natin guys, the deflection obviously is negative, no? Kasi nga downward yung ating deflection, so negative, okay? Tapos ang ine-expect natin of course na rotation, kung mag-drawing tayo ng tangent line dito guys, ang ating mag-drawing na tangent line ay eto, and that is a negative din na tangent na rotation, negative na slope. So ayun, so ang ine-expect natin guys na sign ng letter A at saka letter B ay parehong negative. Okay? So, yun. So later on, i-find out natin kung tama ba yung ating assumption or hindi. So ang una natin gagawin guys is i-compute muna natin guys yung ating mga reactions, mga supports. Okay? So of course, since simply supported lamang yung ating beam, okay, and take note, symmetrical yung ating loading, so ibig sabihin na itong ating reactions ay pareho lamang sila ng amount ng force, amount ng reactions, and hatiin nila nga yung ating total load. So yung ating total load is 24 kilonewtons per meter times 10 meters, that is 240. So bale, tag 120 kilonewtons silang dalawa. So yun, so ilalagay ko lang dito guys yung ating load. So this is 120 kilonewtons and this is also 120 kilonewtons. That is, they are the reactions nga ng supports. Okay. So ang gagawin natin guys of course is sabi nga natin kanina, no, kailangan natin gumawa ng ating equation, moment equation. So all we have to do is i-cut natin siya, i-cut natin yung ating beam. So i-cut natin yung ating beam. So sabihin natin dito natin i-cut yung beam. And then we have to compute for the moment equation. So i-compute natin, mag-create tayo ngayon guys ng ating moment equation. So ito yung ating moment. Okay? So ayun, so ang gagawin natin guys ay i-isolate natin yung left side. So again, yung ating i-isolate is yung left side. So dito tayo sa side na to, okay? Dito tayo sa side na to, okay? So ito ay gagawin nating x, itong distance na to guys ay gagawin nating x. Okay, so ngayon ay gagawa tayo ng moment equation, moment equation as a function of x, okay? So, ayun. So, bali, no? Let us have a summation of moment about this point. Okay? So, again, guys, no, yung ating left side lang yung ating i-consider. So, wag nating i-consider yung right side. Okay? So, ito ay wala na tong sa kabila. Okay? So, let's have summation of moment equals to 0. And let's assume a counterclockwise rotation to be positive. Okay? So, bali at this point tayo mag-moment guys, no? So, sa point na to tayo mag-moment dito mismo sa pinagkatan natin. Ayun. So, bali of course, kasama dito yung M. Kasama pa siya. So, M, it's positive kasi same sila ng direction ng ating positive na orientation. Then, minus 120 times X. Okay? So that is minus kasi opposite ng direction. And then plus 24 times x over 2. I hope nagkakaintindihan tayo guys, no? So this is equals to 0. So again, ang kailangan natin guys is actually equation ng moment. So bali no, ang gagawin natin is itong lahat ng terms na to na may x ay ilalagay natin sa kabilang side ng equation. So bali ang mangyayari is m is equals to 120 then x, okay? Then, minus, okay, so ito ay, sa kabilang side na equation na tayo ha, so ito ay naging plus, tapos minus 12, then x squared. Okay, so ang gawin natin guys, no, actually no, dito hindi naman importante na i-close natin siya sa pointed bracket kasi isang segment lang naman siya, pero para mas masanay lang tayo guys, no, ay ilagay natin dito yung pointed bracket sa may sa kung saan nandun yung ating variable. So again, ilalagay natin yung ating pointed bracket sa kung saan nandun yung ating variable. Okay? So ito na nga guys yung ating moment equation. So ano yung gagawin natin dyan sa moment equation na yan? So itong m na to guys, no, itong equation ng moment ay isa-substitute natin dito sa ating moment equation. So kung natatandaan nyo, diniscuss natin to kanina. So ayun, so ang gawin natin guys ay gumawa tayo ngayon ng moment equation gamit ito. So that will become, okay, so this will be EI, then d squared y over dx squared is equals to m. At ang m nga natin ay 120 then x, ayun, minus 12x squared. Okay, again, no, remind ko lang kayo, actually, hindi importante na maglagay ng pointed bracket dito, no, kasi hindi naman ito magni-negative na x, no, imposible maging negative ito kasi nga, isang segment lamang tayo, no, sa problem na to. Pero, para mas masanay lang tayo, guys, no, ay maggumamit na tayo ngayon ng pointed bracket, no, para dito sa double integration method. Okay? So ayun, so meron na tayo ngayon moment equation, ito na yung moment equation, ito na yun mismo. So ngayon, kailangan natin gumawa naman ng slope equation. So para sa slope equation guys, no, ang kailangan natin gawin ay i-integrate itong ating moment equation. So yun, so isang integrate lang, i-integrate natin isang beses and then yun na yun ating magiging slope equation. Okay? So EI is constant, so of course EI pa din to. Ayun. Then integral of d squared y over dx squared, that will be dy over dx, okay, is equals to integral of 120x will be 120, then x, then squared over 2. Okay, integration man tayo guys, okay. So power formula lang yan, minus integral of 12x squared will be 12, ayun, x, then cube divided by 3. Again guys, no, we are integrating, no, in-integrate lamang natin, integrate. So again, so magiging, yun na nga, EY, dy over dx, ayun, is equals to 120, integral of this is 120x squared over 2 and then minus 12x cubed over 3. So ayun, so ito na nga yung ating magiging slope equation. No, wag natin kalilimutan, meron pa tayong plus C1. Okay, so plus C1. Okay? So this is the constant of integration. I-simplify muna natin guys, no? So bali na mangyayari dito is magiging EY dy over dx is equals to 60 then x, ayun, squared, then minus What is 12 divided by 3? That is 4x, then cube, then plus C1. Okay? So ito yung ating slope equation, pero hindi pa yan yung final natin guys na slope equation, no? Kasi kailangan pa natin mamaya i-compute kung ano yung value ng C1. So pag na-compute natin si C1, yun na yung ating magiging final na slope equation. So ngayon no, ay gumawa muna tayo guys ng another equation, that is deflection equation. So para sa deflection equation, no, kailangan natin i-integrate isa pang beses ito, okay? Integrate isa pang beses. So bali ang mangyayari is magiging EI y, integral of dy over dx is y is equals to integral of 60x squared is 60x, ayun, then cube divided by 3, then minus 4x raised to 4 divided by 4, then plus c sub 1, then x. Enclose lang natin to sa pointed bracket, then plus c2. Okay? So, I hope nagkakaintindihan tayo guys. So, ito na yung ating ito na nga yung ating deflection equation. Ayun. So, simplify lang natin guys no bago tayo mag-move to the next. Okay, so this will be EI y is equals to, this is 20x cube, then minus 4 divided by 4 is 1, so x, ayun, raised to 4 plus c1, ayun, x, and then plus c2. Okay? So, ayun, so ito na nga yung ating deflection equation, pero again guys, hindi pa tayo tapos, hindi pa to finalize na deflection equation, no, kasi kailangan pa nating i-compute si C1 at saka si C2. Okay, so bago tayo mag-move guys, no, ay ilagay natin yung unit natin ng bawat equation, no, bawat unit term, no, yung unit ng bawat term ng ating equation. So, take note, this is moment equation guys. So, we are talking about moment. So, force times distance ito. Diba? Force man yung 120. Kung naalala nyo, ayun, force yung 120 kilonewtons times x. No? That is yung moment. Diba? So, ibig sabihin guys, yung ating unit dito sa moment equation is kilonewton meter. So gusto ko lang ilagay dito yung ating unit, no, para mamaya hindi tayo maguluhan sa pag-convert. Okay. So dito tayo guys sa slope equation. So this is actually integration. So this is di ba in-integrate natin nga yung moment equation. Okay? Again, this is integration of the moment equation. So ang ibig sabihin nito guys is magiging kilonewton force times distance square na ito, no? So, di ba, force man to, tapos naka-square yung x. So, this will be, yung ating unit dito is kilonewton meter square. Okay? So, ganun din dito guys, sa deflection equation, ang ating magiging unit dito will be, naka-cube na yung x, force ito. So, ito is yung ating distance, then naka-cube, then magiging kilonewton cubic meter. So, ito na nga yung ating unit para sa deflection equation. Okay? So, para lang klaro tayo guys sa mga ganyan. Okay, so ngayon, no, kailangan natin ma-compute na guys yung ating values ng C1 at saka yung C2. So, ayun na guys, no, so i-compute natin yung C1 at saka yung C2. So, magba-boundary conditions tayo. So, paano nga ba yung pag-boundary conditions? Okay, so titingnan natin guys yung ating beam. Okay? So, lipat muna tayo sa taas. So, ito yung ating beam, guys. So, sa may leftmost na support, this is a hinge. Tama ba? So, kung hinge ito, guys, no, sabi natin kanina, yung hinge ay bawal magkaroon ng vertical deflection. So, hindi pwedeng mag-move yung member na to vertically. So, ibig sabihin at x, di ba x naman ito, yung at x equals to 0, then yung y must be equal to 0. Yun yung ating first na boundary condition. At x equals to 0, y is equals to 0. Okay. So, ayun. So, at x equals to 0, y equals to 0. So, paano natin magagamit ito, guys? No, all we have to do is gagamitin natin nga yung ating deflection equation. Isa-substitute natin siya dito, guys. And then, yun. I-compute natin kung ano yung pwede natin makompute. So, makukompute natin dito, guys, ay C2. Okay? So, ayun. So, ayun na nga guys, no? So, ito na nga yung ating deflection equation. So, ito yung na-solve natin sa taas na ginawang deflection equation. So ngayon no, ay substitute natin yung ating x equals to 0 tsaka y equals to 0 dito, then makukuha natin si C2. So mangyayari guys, no, so syempre kung 0 si y, then 0 yung buong term dito sa kabila. Then of course ito will be 0, tama ba? Minus 0 pa din ito, then plus 0 pa din ito, then plus C sub 2. So therefore, C sub 2 is equals to 0. Okay? So ayun, so nakuha na natin si C2, ang problema na lang natin ay si C1. Okay? So kailangan pa natin guys ng isa pang boundary condition. So punta muna ulit tayo sa ating beam and then tingnan natin yung isa pang support. Okay, so nandito na tayo guys sa isa pa sa ating beam. So nandito tayo sa ating isang support. So this is a roller. So we know na sa roller, yung roller ay pwedeng mag-move horizontally pero bawal siya mag-move vertically. So ibig sabihin guys, no, wala tayong deflection dito, 0 pa rin yung ating deflection. So at x equals to 10, then y is also equal to 0. Again, at x equals to 10, x man yung ating distance from the left support. So at x equals to 10, y is equals to 0. So yun yung ating gagamiting boundary condition. So yun na nga guys, no? So ito yung ating second na boundary condition at x equals to 10, y is equals to 0. So para makuha natin guys yung C1, then take note yung ating given dito ay x at saka y. So deflection equation pa din yung ating gagamitin. So yung ating deflection equation ay ito, that is EIY equals to, ito na nga. So kinopya lang natin to doon sa taas na ginawa natin kanina. So ayun, so substitute lamang natin guys. So y natin ay 0, so 0 yung buong term dito sa may kabilang side. Then this will be 20 times 10, then cube, minus, this will be 10, then 4, plus C1 times 10. Then of course, yung ating C2 na compute natin kanina, which is 0. So all we need to do guys dito is i-compute yung ating C1. So ang ating C1, okay, is equal to negative 1,000. This is in, okay, again yung ating unit guys ng C1, take note C1 times x ito sa, so ibig sabihin, kilonewton cubic meter yung buong term na to. So ang ating C1 is actually kilonewton square meter. So, ayun guys. So, nasolve na natin guys si C1 at saka si C2. So, C1 nga is negative 1,000 and C2 nga is equals to 0. So, ang gagawin natin ay babalikan natin yung ating mga equations kanina, yung sa slope equation at saka deflection equation, para makompleto natin nga yung ating equations na yon. Okay? So, punta tayo sa taas guys. Okay? So, ito yung ating slope equation, no? Kompletohin natin yung ating slope equation. So, yung ating slope equation is, ayan, EI dy over dx is equals to 60x squared minus 4x cubed, then plus C1. So this is minus 1,000. Okay, so ito na nga yung ating slope equation guys. Okay, tapos dito tayo ngayon sa ating deflection equation. So, isulat ko na lang guys, no? So, this is EIY okay, so ayun. So, EIY equals to 20x cubed minus x to the fourth minus 1,000x. Okay, so yung C2 natin ay 0. So, hindi na natin siya inilagay. Okay. So, ayun guys, no? So, nakompleto na natin yung ating dalawang equations, yung slope equation tsaka yung deflection equation. So, ito lang namang dalawa yung ating kailangan sa pag-solve nga ng ating problem. So, ayun. So, yun. So, balikan na natin ngayon guys yung ating problem, no? Para ma-solve na natin nga yung mga hinahanap dun sa problem. Okay? Ayun, so ang hinahanap natin guys, no? Balikan lang natin. So, letter A, determine the rotation of the beam at a point 4 meters from the left support in radians. So, ibig sabihin guys, ang kailangan natin dito is yung rotation ng beam, that is yung theta, okay? Or dy over dx yung kailangan natin dito sa letter A, okay? So, isulat lamang natin. Ayun, so dito tayo. Okay, so para sa letter A, ang kailangan natin is yung theta, or that is yung dy over dx. Diba sabi nga natin that theta at dy over dx ay pareho lamang to. Okay, so dy over dx ang kailangan natin at at value ng x na equals to 4 meters from the left support. So from the left support man talaga yung ating pag-measure ng x, di ba? Ito man yung ating left support. So at 4 meters yung ating kailangan na value ng x. Okay? So ang gagawin natin guys is of course, kung gagamitin natin since slope ang kailangan, then gagamitin natin yung slope equation. So tingnan natin yung ating slope equation. So, ayun guys. So, ito yung ating slope equation. So, ayun. So, gagamitin natin ito para pag-solve nga ng dy over dx. So, dy over dx ang ating kailangan dito. Okay. So, isolve natin siya guys. So, bali no, at x equals to 4 ha. Okay. So, bali ang mangyayari dito is ei, then dy over dx is equals to 60 times 4. X natin take note ay 4, then squared, minus 4 times 4, then cube, then minus 1,000. Okay? So, isolve natin guys sa kabilang side ng equation na ito. Ito lang yung ating masosolve dito. So, ang mangyayari ay magiging equal to negative 296. This is in kilonewton square meter. Okay. So, take note, ang kailangan natin is dy over dx. So, bale no, magiging negative 296 kilonewton square meter divided by EI. Okay? So, ayun. So, ang kailangan lamang natin guys dito is i-compute muna si EI, no? And then i-substitute dito. Then, makukuha na natin yung dy over dx, which is yun yung tinatanong sa problem. Okay? Okay. So, i-solve muna natin guys si EI. So, sabi dito sa problem, yung E nga daw is 200 gigapascal and yung I nga is 240 times 10 to the 6 millimeters to the 4th. So, ayun. So, 200 gigapascal at 240 times 10 to the 6. So, yun yung ating mga values ng E at saka I. So, i-multiply natin lang naman natin sila guys and then makukuha na natin nga yung EI. Okay? So, dito tayo. Okay? So, this will be EI. EI yung ating sinusolve. So, again, yung ating E dito is equals to 200 gigapascal. Okay? So, this is 200 gigapascal. So, yung 200 gigapascal, guys, is 200 times 10 to the 9. So, kung gagawin natin siyang megapascal, take note that megapascal is Newton per square millimeter. So, kung gagawin natin megapascal yung 200 gigapascal, magiging 200 times 10 to the 3. This will be in megapascal na siya. Tama ba? Kaya nandito naman na yung 3. Okay? So, yung megapascal is Newton per square millimeter. Ayun. Okay, this is the modulus of elasticity. Times I, sabi natin yung I kanina is na given is 240 times 10 to the 6. This is in millimeters to the 4th. So, bali, ang lalabas dito guys, nating unit will be, makakansel si millimeters square at may matitira na square dito sa taas. Okay? So, ang ating EI will be equal to 4.8 times 10 to 13 Newton millimeter square. Okay, so ito yung ating EI. Okay? So, ayun guys, no? So, all we need to do is to substitute pero kailangan kasi na yung ating ditong nasa ibabaw ay maging maging Newton millimeter square muna siya guys, no? So, i-convert natin muna yung nasa ibabaw to Newton square millimeter. So, siguro, no, i-multiply natin ito ng 1 kilonewton is 1,000 newtons times 1 meter is 1,000 millimeter, then square natin. Ayun. Okay, so pwede na siya guys, no? I-solve na lang. So, negative 296 times ito divided by EI. Ito yun. So, ang mangyayari guys, take note ay na-cancel na nga dito si kilonewton. Okay? Then, Newton na yung ating unit. Tapos si meter square ay mga-cancel. At ang magiging unit natin is millimeter square. So, Newton millimeter square na yung ating nandito sa ibabaw. Okay? So, Newton millimeter square dito sa ilalim. So, magka-cancel lang silang dalawa. So, therefore, radians yung ating unit nga ng ating slope. Okay? This is in radians. Okay? So, kung tinatanong yung angle, that is pwedeng radians or pwedeng degrees. Angle man to, di ba? Yung dy over dx, tsaka yung theta, ay pareho lamang. They are both angles. So, this is in radians. Ayun. So, yung lalabas guys dito, na value ng dy over dx is equals to negative 0.0 0.006167. This is in radians. So ayun, so ito na nga yung ating value ng dy over dx. Okay? So tama ba yung ating assumption kanina, guys? Diba? Negative man yung ina-expect natin. Ayun. So tingnan nga natin ulit. Ayun, so tingnan natin, tingnan nyo natin guys, diba sabi natin na ang ina-expect natin na sign para sa letter A is negative, and negative din dapat yung ina-expect natin na deflection sa letter B. Okay, so tama yung ating letter A, negative, so sa letter B na lang yung problema natin. So letter B, determine the deflection at a point 4 meters from the left support in millimeters. Okay, so madali lang to, no? I-solve natin siya. So ayun, so deflection at distance x from the left support. So ibig sabihin guys, yung hinahanap natin ay y, the value ng y at x equals to 4 meters. So of course, since deflection na nga yung hinahanap, then ibig sabihin, ang gagamitin natin dito na equation ay yung deflection equation. So ayun, so ito na nga guys yung ating deflection equation. So kinopya ko lang siya galing sa ating sinolve kanina. So ayun, so EIY, ito na nga yun. So all we need to do is to substitute nga yung ating x na equals to 4 meters at saka yung EI na na-solve natin kanina. Ayun. So ayun, so gawin na natin to. So bali ang mangyayari is, wait, this will be EI y is equals to 20 times 4 cube minus 4 to the 4th minus 1,000 times 4. Okay? So ang lalabas dito guys is this will become equal to negative 2976. Okay, this is in kilonewton cubic meter. Okay, ito yung sinolve natin. This is kilonewton cubic meter. Okay, then since y yung ating hinahanap, then divided by EI. Okay, so ayun, so madali lang naman to guys, no? Since yung ating EI nga is naka Newton square millimeter, di ba? I-convert natin ito to Newton cubic millimeter. So ang mangyayari dito guys is equals to negative 2976. Take note, pwede lang naman natin guys, no, i-ano na lang, no? Hindi na tayo mag-multiply ng 1 kilonewton is 1,000 newtons, gano'n. Kasi nga, madali lang naman to. So meron tayong 3 dito, then meron tayong meter na naka-cube. Okay, so all we need to do is to convert this to Newton, ito is to millimeter. So meron tayong 3 dito, dito is 3 to the cube, that is 9. So that is 12 lahat. So times 10 to the 12. 3 plus 9, no? Kasi 3 cube. Okay? Ayun. So times 10 to the 12 divided by EI. Okay, so all we need to do again is substitute natin yung EI. Ano nga yung value natin ng EI kanina? That is 4.8 times 10 to the 13. This is Newton square millimeter. Okay, so again, yung unit na nito is Newton cubic millimeter. Dito sa baba is Newton square millimeter. So cancel sa Newton, square millimeter cancel, at ang matitira na lang ay millimeter. So ayun guys, no? So ang lalabas sa sagot dito is y is equal to negative 62. This is in millimeters. So ayun. Okay. So that's it guys. So ito na nga yung ating final answer. So y is equals to negative 62 millimeters. Okay. Or pwede natin din isulat yung ating sagot. No? I-rewrite natin guys yung ating sagot. So y is equals to 62 millimeters and this is downward deflection. Ayun. Tapos dito naman sa slope, kapag nire-write natin yung ating sagot dito, wait lang. Nasaan na? Okay. This will be dy over dx is equals to 0.006167 radians. Ayun. Tapos, ilagay lang natin dito yung ating direction. So, ganito man yung ating angle. No? Kasi ito yung ating tangent line. Ito yung ating tangent line. So, ito yung ating angle. Okay? So, that is our answer. So, ayun guys, no? So, if you want to screenshot, okay? So, sige nga, balikan natin guys yung ating problem. So, ayun. So, yung una natin ginawa is sinolve natin yung ating mga reactions. Ayun. And then, kinuha natin yung ating moment equation with respect to x. Tapos of course, no, gumawa tayo ng moment equation, ito na nga yun. And then integrate natin siya para makuha si slope equation, at ito na nga yun. And then integrate pa natin para makuha si deflection equation. And then after that, no, syempre unknown pa si C1 at saka si C2, then gumamit tayo ng boundary conditions para ma-solve si C1 at saka si C2. So ito na nga yung nangyari sa ating sa ating solution. Ayun. Tapos na-finalize na nga natin si slope equation at si deflection equation na ginamit natin sa pag-solve ng mga tinatanong sa problem, wherein yun yung slope at saka deflection at a distance na 4 meters from the left support. So ito na nga yung ating solution para sa letter A. Ito yun. Ayun, paki-screenshot nyo na lang. Okay? And then para sa letter B ay ito yun. Okay. So that's it, guys. So meron pa tayong isang problem na isosolve. So yung ating next na problem, guys, ay etong problem na ito. So isolve natin siya sa next na video, no, para hindi masyadong mahaba itong video na to at pwede nyong ulit-ulitin. Okay, so that's it, guys. So yun lang. So ayun, so see you sa next video para sa example problem number 2. Ayun, so yun.